Year 9 Turning Forces. This video explains how we can increase the size of a force using a lever. In this diagram, we have a person using a lever to lift a heavy barrel. The person cannot exert enough force upwards to lift the barrel, so instead they use a lever, which multiplies the effort, creating a turning force or moment on the barrel. If the distance between the person and the pivot, also known as the fulcrum, is greater than this distance here, and times by the effort is greater than this distance times by the weight of the barrel, then the person will be able to raise the barrel up into the air. This is shown using the equation for turning force or moment. Force times distance, where the force is the downward effort applied to the lever, and the distance is the distance between the applied force and the pivot. This produces a moment. Moments or turning forces are really useful in everyday life. There are lots of examples in the home where levers are used to make jobs easier. For example, opening a cupboard door. There is a lever between the handle and the hinges. Using a bottle opener to take the cap off a bottle involves a lever. A screwdriver produces a turning force which makes it easier to loosen or tighten screws. And a spanner is another tool where a lever is used in order to make it possible to tighten or loosen nuts. Have a look around your home and see if you can identify any other levers. We can also use the idea of turning forces or moments to work out whether scenarios will be balanced. In this scenario, we have a heavy barrel suspended from a beam. Without the downward force from the person on the right, the barrel would come crashing down. The person on the right exerts a downward force. This force, times by the distance of 3 meters, produces a clockwise moment. If this clockwise moment is equal to the anti-clockwise moment, which is 1 meter times 1,800, then the scenario will be balanced. It is common for this to be given as a question, with one of these values, either a distance or a force missing, and the person completing the test being asked to work out the missing value. In this case, you work out the moment on one side, for example 1 times 1,800 newtons, and if the value that you needed to determine was the distance, you would then ask yourself what you need to times 600 by in order to get 1,800, which of course is 3 meters. So in conclusion, we use the idea of levers to increase the size of a force, producing a turning force, which is also called a moment. The equation for moment is force times distance, where the distance is the distance between the force and the pivot. And when moments either side of a pivot are equal to each other, i.e. the anti-clockwise moment equals the clockwise moment, then we know that the forces or the moments are balanced and you have a balanced scenario.